Welcome to Tungal Online Classes. In previous video, we had discussed the concept of apparent weight of a person in a lift. Apparent weight of a person in a lift. So in this video, we are going to discuss change in momentum of a body in a different cases. The change in momentum of a body in a different cases. So already we know that the momentum means it is the product of mass and velocity. It is the product of mass and velocity. The linear momentum, it depends on mass as well as it depends on the velocity. Okay, see here. So consider a body of mass m. So in this case we are considering, so this is a body of mass is m. Initially this body is moving with velocity, that is u. Initially this body is moving with the velocity, that is u. After some time its velocity changes to v. After some time its velocity changes to v. So then the initial momentum of this body, that is p1, is equal to product of mass into velocity, that is m into u, and that is p2 is equal to, after collision the velocity of this body changes to u to v. So then the final momentum is the product of mass into velocity. Here p1 indicates that initial momentum of the body and p2 indicates that final momentum of the body. Okay, see here. So in this case we are going to find out the change in momentum. So change in momentum is equal to, that is the final momentum minus initial momentum. Here the final momentum is, that is p2, the initial momentum is p1. So this is equal to p2 minus p1. So next we want to calculate the magnitude of change in momentum. The magnitude of change in momentum, that is equal to the magnitude of p2 minus p1. The magnitude of p2 minus p1. So this is equal to, so from the standard relation this value is, that is p1 square plus p2 square minus 2p1 p2 cos theta. 2p1 p2 cos theta. So this is a change in momentum of the body in this case, right? So here the magnitude of change in momentum, that is equal to the magnitude of p2 minus p1. So this in the form of magnitude of a1 minus a2. So with the help of a parallel vector addition, that is under root of a1 square plus a2 square minus 2a1 a2 cos theta. Similarly here the magnitude of p2 minus p1, final momentum minus initial momentum, so that is equal to under root of p1 square plus p2 square minus 2p1 p2 cos theta. So this is a change in momentum in this case. Okay, the next one. So consider a body of mass m. So consider, in this case, this is the rigid surface or the wall. A body of mass is m. It is moving in this direction with some velocity, that is v. So here v indicates that the initial velocity of that body. So here this body of mass is m and it is moving with a velocity v in this direction after collision. So after collision that body immediately comes to rest. After collision that body immediately comes to rest means the final velocity of that body is 0. Final velocity of that body is 0. Okay, see here, then the change in momentum. So change in momentum, that is equal to p2 minus p1 or final momentum minus initial momentum. Here the final momentum, it is a product of mass into velocity, that is the final velocity. Here the final velocity is 0 minus initial velocity is m into v. So then the change in momentum, that is equal to minus m into v. Then the magnitude of change in momentum, that is equal to m into v, right? So the magnitude of change in momentum, that is equal to m into v. Okay, so in this case we are considering a body of mass m. It is moving along in this direction with a velocity v. After collision that body immediately comes to rest means the final velocity of that body is 0. So then the change in momentum, the magnitude of change in momentum, that is equal to mass into velocity. Okay, so in the next case, right? So in next case, in above case, the mass of the body, it is moving with initial velocity u in this direction. After collision that body comes to rest. But in third case, after collision that body rebounds with some speed that is v2. Okay, see here in the third case, the body of mass m, initially it is moving with velocity v1, it collides or it hits the wall. After collision, that ball or that body, it is moving with the speed of v2. So then find out the change in momentum here. In this case, the initial velocity, that is u is equal to initial velocity is v1. So next one, the final velocity, that is v is equal to v2. So then the change in momentum, that is equal to p2 minus p1, change in momentum, that is equal to p2 minus p1. Here p2 means the momentum of the ball after collision. So in this case, this body is moving in this direction, so the velocity of this body is considered as a positive. But in this case, after collision, that body, it is moving with the speed of v2 in this direction. So then the velocity of this body becomes, that is minus v2. So then the momentum means, that is minus of m into v2 minus the initial momentum is, that is m into v1. Okay, see here the momentum of the body after collision, it is negative because it is moving in opposite direction to the initial direction of that body. So then the magnitude of change in momentum, that is equal to magnitude, take minus m common here, then it becomes v1 plus v2, magnitude. So this is equal to m bracket of v1 plus v2. So here the magnitude of change in momentum, that is equal to the magnitude of minus m bracket of v1 plus v2 is equal to, so the magnitude of this value is always positive. So then change in momentum, that is equal to m bracket of v1 plus v2. Okay, see here the next case. In fourth case, so if the body is moving with a speed or with a velocity, that is v, so after collision it rebounds with the same velocity or it rebounds with the same speed. So that means here v1 and v2 are both same. So v1 and v2 value are same. So then the change in momentum, in that case, so here v1 is equal to v2 is equal to v. In this case, we are considering a body of mass m, it is moving with a velocity v. After collision, it rebounds with the same speed. So then the initial velocity and after collision the speed is the same, that is v. So then the change in momentum, the magnitude of change in momentum, that is equal to m bracket of v1 plus v2. But in this case, v1 and v2 value is, that is v. Okay, see here the change in momentum, the magnitude of change in momentum, that is equal to m bracket of v plus v. So this is equal to 2mv, the magnitude of change in momentum, its value is 2 into m into v. Okay, the next one, fifth one. Okay, consider here, so this is the wall or the rigid wall. So if a body of mass m, it moves with a velocity, that is u, and it hits the wall, after collision that body is moving with the same speed, So in this case the velocity of this body makes an angle theta with respect to normal. This is the normal here. So in this case, this body or the velocity of this body makes an angle theta with respect to the normal. Okay, see here the mass of this body is m and the velocity of this body is, that is v, right? So this velocity is a vector quantity. It can be resolved into two components. One is a horizontal component and one more is a vertical component. So in this case, it makes an theta with respect to this, means this is our horizontal component. The horizontal component value is, that is v into cos theta. Horizontal component value is, that is v into cos theta, and here vertical component is, that is v into sin theta. Okay, see here again, after collision it makes an angle theta with respect to this normal. So then this becomes the horizontal component and this becomes the vertical component here. The horizontal component value is that is v into cos theta, and here the vertical component is v into sin theta. So in this case the magnitude of these two components are same, but both are in opposite direction, both are get cancelled. So then the change in momentum along this direction, so both having the same direction, that is a v cos theta and v cos theta. So then change in momentum, so change in momentum is equal to 2 into m into v cos theta, right? Change in momentum is, the momentum is product of mass into velocity. Here the velocity horizontal component is v cos theta, then the momentum becomes mv cos theta, and here the momentum of this body horizontal component is v cos theta, and the momentum of that body along horizontal direction is mv cos theta. mv cos theta plus mv cos theta, that is equal to the magnitude of change in momentum, that is equal to 2 into m into v cos theta, 2 into m into v cos theta. So these are the change in momentum of the body in the different case. The first one, the body of mass is m and it is moving with initial velocity u. After some time its velocity changes to v, so then the magnitude of a change in momentum is the magnitude of p2 minus p1, that is equal to under root of p1 square plus p2 square minus 2 p1 p2 cos theta. And the next one, so in this case the body of mass m, it is traveling in this direction, or it is moving with the velocity of v and hits the wall. After collision that body comes to rest. So then the change in momentum, the magnitude of change in momentum is, that is m into v. And the third case, if the body of mass m, it is moving the velocity v1 and it collides with a wall, after collision it rebounds with a speed of v2. So then the magnitude of change in momentum is m bracket of v1 plus v2, m bracket of v1 plus v2. So in the next case, if the body is moving with the velocity v, after rebounds it moves with the same speed, means in that case the v1 v2 value are same. So initially it is moving with the velocity v and after rebounds it is moving with the speed is, that is v. So then the change in momentum is equal to 2 into m into v. So the next one, if the body of mass m, it is moving with the velocity v, it makes an angle theta with respect to the normal. So after collision that body is moving with the same speed. After collision that body is moving with the same speed, then the change in momentum of that body, that is equal to 2 into m into v cos theta. So 2 into m into v cos theta. See here the next one, sixth case, right? So in this case, so consider this is a wall. So if a body of mass m, it moving the velocity that is v, it collides with a wall and it makes an angle theta with respect to the wall. In previous case this makes an angle theta with respect to the normal, but in this case it makes an angle theta with respect to the wall. So after collision this body is with the same velocity or the same speed. So here we are considering the body of mass m, it is moving with the velocity v. After collision it makes an angle theta with respect to the wall, and after collision that body it moves with the same speed, So then find out the change in momentum here. So then the change in momentum, so the magnitude of change in momentum, that is equal to, okay, so here in this case the velocity can be resolved into two components, one is a horizontal component and one more is the vertical component. So in this case it makes an angle theta with respect to this one, means this is the horizontal component. Then horizontal component of velocity is, that is v into cos theta, and here this becomes v into sin theta. Here is also it makes an angle theta with respect to this one. The mass is m and it is moving with the same speed is v. So then it can also resolve into two components. So this is the horizontal component, that is a v cos theta, and this is the vertical component, that is a v sin theta. So here both having the same magnitude but they are moving in opposite direction, both are get cancelled. So then the momentum along this direction, so in this case the v sin theta and v sin theta both are in the same direction, then the change in momentum in this direction is, that is 2 into m into v sin theta, 2 into m into v sin theta. See here, So this is the 5.19 NCERT problem. Okay, see the problem here. A batsman deflects a ball by an angle of 45 degree. They are given the angle is 45 degree without changing its speed, which is equal to 54 km per hour. So that means, so here the initial speed and after collision the speed both are same. Next, what is the impulse imparted to the ball? So here already we know that the impulse means it is a product of force and time, and that is equal to change in momentum. That is equal to change in momentum. Okay, see here in this case we are going to find out the what is the impulse, right? So first write down the given terms here. So the mass of the ball is given here. The mass of the ball is that is 0.15 kg. The mass of the ball is 0.15 kg, and the angle is given theta is equal to 45 degree. And the next one, the speed. Here both the speed is same, the initial speed and after collision, that is the final speed, both are same. Then v is equal to 54 km per hour. Kilometer per hour. Convert this into meter per second means just we are multiplying by this 5 by 18. So this is equal to 15 meter per second. This is equal to 15 meter per second. Okay, see here. So let us assume that this is a bat. Let us assume that this is a bat. A ball of mass m, it hits the bat, and after collision it is moving with the same speed. After collision it is moving with the same speed. Here this mass indicates that m and the velocity indicates that is v, and it makes an angle theta. So the angle between these two vector, that is 45. The angle between these two is 45 degree, and this is a normal to the surface. Normal means perpendicular to this surface. So then the angle between these 2 points, the angle between the normal and the velocity vector, so that is 22.5. 22.5. So here the total angle is 45 degree. It can be divided into 2. So that is 22.5, and this also becomes 22.5. 22.5 degree. So here this velocity vector makes an angle theta with respect to this one, means this is the horizontal component. So that is mv. So here the velocity horizontal component is, that is v cos theta, and this is the v sin theta. Here is also same. It makes an angle theta with respect to this, means v cos theta, and this is the v sin theta. So already we have discussed this concept. Then the formula to calculate the change in momentum is, see here, the impulse that is equal to force into time. This is standard formula, that is equal to change in momentum. So here we want to calculate the impulse, right? So then impulse is equal to, that is change in momentum. So change in momentum is, that is P2 minus P1, right? Okay, already we know the standard formula for this one. Change in magnitude of a change in momentum, that is equal to 2 into m into v cos theta. 2 into m into v cos theta. Here this is 2 as it is. Then mass. The mass of the ball is given, that is 0.15 into velocity is 15 into cos of 22.5. Cos of 22.5. Okay. Cos of 22.5. Okay. This is equal to 2 into 0.15, next into 15 into cos of 22.5, its value is, that is 0.9238. Its value is 0.9238, and multiply this one, we will get the final answer is 4.157. 4.157 Newton second. So this is the impulse, that is J is equal to 4.157 Newton second. Okay, see here. So the problem number 5.16 NCERT problem here. So in this problem they are given two masses 8 kg and 12 kg are connected at the two ends of a light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when the masses are released. When the masses are released. So in this case, take g is equal to 10 meter per second square. 10 meter per second square. Okay, see here. So this problem is based on mass pulley problem. Okay, see here they are given the two masses. So consider this is one mass A and this another mass B. The mass of first one is that is 8 kg and the mass of second one is that is 12 kg, and it is passing over the pulley, and it is passing over the pulley, right? This is a frictionless pulley. So here we are going to find out what is the acceleration of this system and what is the tension developed inside the string. Okay, see here, the first one, draw the free body diagram for body A and body B. So in this case, first we are going to determine what is the direction of a tension here. What is the direction of a tension? So in this case, this is a point of contact. The direction of tension is always away from the point of contact here, and this is a point of contact, and this is a direction of a tension. This is a direction of a tension, and this string is a light and inextensible string. So that means the tension inside the string at any point is same. Okay, see here. So in this case, the mass of first body is 8 kg and mass of a second body is 12 kg, right? So mass of a second body is 12 kg. So in this case, this system, it is moving in this direction. Okay, see here we are going to draw the free body diagram here. For first body, consider this A body and this is a B body. For A body, the free body diagram is, consider this a point object, and here the weight is acting in the downward direction. At the same time, the tension is acting in upward direction. For the second body B, here the weight is acting in the downward direction and the tension is acting in the upward direction. So here the weight of the body is more comparing to the first body. So then this system is moving in this direction. This is the direction of acceleration. So here, if this body is moving in this direction and this body is moving in the upward direction, so here this is the direction of acceleration. So first we have to determine what is the acceleration of the system. So already we discussed this concept and we have derived one formula to calculate the acceleration of that system, that is A is equal to, acceleration is equal to the difference in their mass. So m2 minus m1, m2 minus m1 into acceleration due to gravity divided by total mass of the system, m1 plus m2. So just remember this formula here. So how to remember this formula? So then acceleration is equal to difference in their mass into acceleration due to gravity divided by the total mass of the system, right? We can easily remember this one. So acceleration of the system is equal to difference in their mass into acceleration due to gravity divided by the total mass of the system. Okay, substitute here. Then acceleration, that is A is equal to, acceleration that is A is equal to, what is the m2 value here? The m2 value is that is 12 kg. m2 is that is 12 kg minus m1 is that is 8 kg into acceleration due to gravity is that is 10 whole divided by m1 plus m2, that is 12 plus 8. 12 plus 8. Okay. So then this becomes 12 minus 8. 12 minus 8, so that is 4 into 10 divided by 12 plus 8 means that is 20. So this get cancelled. So 2 1s are 2 2s are. So then acceleration of the system is that is 2 meter per second square. So this is the acceleration of the system. Okay, see here. So first we are going to draw the free body diagram for these two body. For first body, the weight of the body is acting in the downward direction and the tension is acting in the upward direction. So here is also same, the weight is acting in downward direction, tension is acting in the upward direction. So here the weight of the second body is more comparing to the weight of the first body. So then this body is moving in the downward direction and this body is moving in the upward direction. And here this is the direction of acceleration. Okay. So here we are going to determine the acceleration value. So that formula is difference in their mass into acceleration due to gravity divided by total mass, right? The difference in their mass is that is 12 minus 8 into 10 divided by 12 plus 8, that is equal to 4 into 10 divided by 20, that is equal to 2 meter per second square. So this is the acceleration of this system. Okay, so next we are going to determine the tension inside the string. Okay, from the free body diagram A, here the net force acting on this system from free body diagram, FBD means free body diagram of A first body. Okay, so here the net force that is equal to, in this case this body is moving in upward direction, means the tension is more comparing to the weight. So the net force that is equal to tension minus weight. Net force is nothing but mass into acceleration, that is m into a, that is equal to tension. Here minus weight means m into g, m1 into g. Okay, see here. So in this case we want the tension value. So then tension is equal to, take this term this side, that is m1a plus m1g. So take m1 common, then it becomes a plus g. Then the substitute the values here. The m1 value is 8. M1 value is 8 and acceleration value is, that is 2 meter per second square, plus this is 10. Acceleration due to gravity value is 10. So this is equal to 8 bracket of 12. So this is equal to 8 into 2 is 16. 8 on the 8 plus 1, that is 96. So the tension inside the string, so that is 96. The tension inside the string is 96. Okay, see here. So this is the acceleration of the system, and to find out the tension from this free body diagram, you write the equation. The net force equal to tension minus weight. Net force is nothing but product of mass into acceleration, that is equal to tension minus mass into acceleration due to gravity. Okay, simplify this one, we will get m1 bracket of a plus g, substitute all the values. 8 bracket of 2 plus 10, this is 12. 12 into 8 is 96. Tension developed inside the string is 96 Newton. See here, so in this problem, so this is a 5.15 problem. Two bodies of masses 10 kg and 20 kg respectively, kept on a smooth horizontal surface, are tied to the ends of a light string. A horizontal force F is equal to 600 Newton is applied to A and second on B along the direction of a string. What is the tension in the string in each case? What is the tension in the string in each case? So in this problem they are given the two bodies of masses, that is one is a 10 kg and another is 20 kg. Both are connected with the help of a light string. So if the force F is applied to the first body, then what is the tension developed inside the string? And if the same force F is applied to the body B, then what is the tension developed inside the string? Okay, see here. So first write in the given terms here. Given terms, mass of first body m1 is 10 kg, m2 is 20 kg, m2 is 20 kg. So this next force is equal to 600 Newton. Next the force is equal to 600 Newton. Okay, see here. So consider this is one body A and this is another body B. So both are connected with the help of a light string. See here, in this case we are applying the force F in this direction, the second case. So first we are going to apply the force on the second body. We are going to find out what is the tension developed inside the string. Okay, see here. So this is a point of contact between the body and the string, and this is a point of contact between the body and the string. So this is the direction of a tension. This is the direction of a tension. So the direction of tension is always away from the point of contact. Okay, see here. The first one, we are going to determine what is the acceleration of this system. So in this case we are consider this as a single system, then acceleration is equal to net force divided by, or acceleration is equal to applied force divided by total mass, that is equal to total mass. Here the force is, that is given 600 Newton, the force is 600 Newton, and the total mass means the mass of first body plus mass of second body. The mass of first body is 10 kg and the mass of second body is, that is 20 kg. Mass of the second body is 20 kg. So the total mass is 10 plus 20. So this is equal to 600 divided by 30. So this is equal to 20 meter per second square. So this is the acceleration of the system, that is 20 meter per second square. Okay. So next we are going to determine what is the tension developed inside the string when the 600 Newton force is applied on the body B. So this is the second case. Okay, see here. So for this one we have to draw the free body diagram for body A and body B. For body A, see here, the weight of the body is acting in downward direction, the normal reaction is acting in upward direction, and this is the direction of a tension, and this is the direction of a tension, right? For second body, so this is for body A, and for second body B, so in this case the weight is acting in the downward direction, normal reaction is acting in upward direction, and here this is external force, that is F, and this is the direction of a tension, right? So here we are going to determine the tension value. So from this relation, the net force acting on this system, that is equal to tension. Okay, see here. So net force, that is equal to tension, right? So then the net force is nothing but mass into acceleration. So the mass of this first body is m1 into acceleration is a, that is equal to t here. Then t is equal to the mass of first body is 10 kg and acceleration of this one is, that is 20, right? So this is 10 kg and the acceleration is 20. This is equal to tension inside the string, so that is 200 Newton, right? So when we are applying the force 600 Newton on the second body. Okay, similarly we are going to determine if the same force is applied on a body, then what is the tension inside the string. See here, the first case, we will redraw the diagram here. This is first body A, its mass is 10 kg, and this is second body B, its mass is 20 kg. Both are connected with the help of a light string, and this is the direction of a tension here. The direction of tension is always away from the point of contact. These two are the point of contact, and these two are the direction of a tension. In this case, we are applying the force F in this direction, that is 600 Newton. So we are going to find out what is the tension inside the string. Okay, see here, first we have to draw the free body diagram for this one. For body A, so consider this a point object, weight is acting in downward direction, and this is a normal reaction. Weight is in downward direction, normal reaction is acting in this direction, and the tension is acting in this direction, and this is a horizontal force, that is F, right? So next for body B. For body B, consider this body as a point object. The weight is acting in downward direction. This is a normal reaction acting in upward direction, and in this direction, this is a direction of a tension. So from this diagram, the net force acting on the body B, the net force acting on the body B is equal to, here the net force is equal to tension. So tension is equal to, net force is nothing but m2 into A. m2 means that is the mass of the second body, that is 20, and acceleration of the system is 20. So 20 into 20 is, that is 400 Newton. So tension inside the string is, that is 400 Newton. So here the acceleration of the system is 20 meter per second, and if the force applied on the second body B, then the tension developed inside the string is, that is 200 Newton. The same force is applied on the first body, the tension developed inside the string is, that is 400 Newton. Okay, thank you.